The next thing we're going to start talking about is we're going to start talking about tanks, okay? And when we look at this picture here, you'll see the Delvin water tower. And of course, when most people see this water tower, what they think of is the quantity of water that this tower holds. It holds thousands to maybe hundreds of gallons of water. I mean, millions of gallons of water. So people think of it as a tank being something that, well, it's the water storage vessel. But tanks are really more than that. What they really are is they really are a pressure vessel. And so when you've got this water tower, from the top of the water in the tower to the base, the ground level, that's pressure that we're going to have in our city systems, all right? So if we were to take that 115 feet of head that we've got here, multiply it by our multiplier, which is 2.31, we find that that's going to equal 49.78 PSI, which we'll round off to 50. And so what we're basically saying is if I've got 115 feet of water in this water tower, there's 50 PSI on my system. Now, it would be absolutely wonderful if everybody had a water tower in their backyard. Well, maybe not. Okay? So because of that, tanks were invented. And this is what we call an air-over-water tank. Air-over-water tank. Now, what that means, and we'll take a closer look at them in a minute, what that means, though, is that the air and the water are touching one another. Okay? The next tank that we're going to take a look at right next to it there is called a pre-charged tank. Pre-charged tank. In a pre-charged tank, there's a separator. And again, we'll take a closer look at them. There's a separator between the water and the air. And you're going to see what that does in just a couple of minutes here, okay? So, on our next slide, I want you to see that there are some similarities between the two systems. For example, both systems are going to have a pressure switch on them. Now remember, all the pressure switch does is turn the pump on and turn the pump off. All right? Both systems are usually going to have a pressure, and I say usually because it's not recommended that you have one, although it should be. But most people have them in there because they want to see what pressure their system is at. And so they put a pressure gauge in there. Right? If you don't have a pressure relief valve in there, shame on you. It is the cheapest insurance policy you're ever going to buy, and so we would strongly encourage you to put some kind of pressure relief valve in. Should something happen and that pump not turn off, it can build up pressure that can hurt your system. So to eliminate that, we want to make sure that you go ahead and have that pressure relief valve in place. Just a safety factor, okay? Now, let's start looking at a couple differences. And the first difference we're going to look at here is the fact that why you need that. On an above-ground system, that air volume control is going to be connected to the pump via a tube that's going to get connected to the suction side. We're going to show you how all that works here in a few minutes. That's part of our presentation, okay? Now, this box here represents what we're going to call a 220-gallon air-over-water tank. What does that mean? What it simply means is this. With no air in this tank will hold 220 gallons of water. All right? That's what it means, and that's why they call it a 220-gallon air-over-water tank. Now, of course, if you've got all water in there, it's not going to do any good, so we got to have some air in there too. So there are three basic things going on in this tank, and I don't want to have separators because there really is not separators in the tank, but, all right, we're going to start out by telling you that this system is a 30-50 pressure system, all right? One of the three things that are in that tank is called drawdown. Drawdown is the usable amount of water that you're going to have between 30 psi and 50 psi. So when the pump turns off at 50, the air pressure in the tank is going to push that drawdown water out until you get to 30, and then it turns the pump back on. So when they talk about a 30-50 pressure switch, that's what they're doing, all right? Now, you may remember from some of our hydraulic courses that water is compressible. But this next section that I'm putting in here is going to be called compression water. Now, compression water simply means that we're going to use this water to compress something else. And of course, the other thing that's in this tank is air. So we're going to use that water to compress the air. All right? Now, of course, what happens is this. Air molecules and water molecules are very similar. Right? So, of course, what happens is that the air molecules and the water molecules start to mix. And as you pull water out of the tank, air comes out with it. Now, if you don't do anything about it, this is what's going to happen. You're going to start losing air and drawdown at the same time. And so you'll see our picture here is going to show us that air and drawdown are going to disappear. When they disappear, the tank is now completely full of water. All right? So we have a question for you, and if you would raise your hand, what do you call a tank when there is no air in it? You call that waterlogged. Okay? Now, of course, the point is what's the real name for a waterlogged tank? And the real name for a waterlogged tank is a big piece of pipe. Because in reality, that's all that it is. It's just a big piece of pipe in your system. Okay? So we're going to go back to our original tank here. And back to the fact that we've got some compression water. It's not completely full of compression water. We've got some air, and we've got some drawdown. All right? Remember, we're running a 30-50 pressure switch here. Okay? With a 30-50 pressure switch in a 220-gallon air-over-water tank, according to Boyle's law, you should have about 26 gallons of drawdown. Now remember, the drawdown is the amount of water you're going to get out of the tank between the 50 psi when the pump turns off and the 30 psi when the pump turns back on. Okay? This is a picture of what we're going to call a pre-charged tank. Now remember, in our very first picture, you saw the two sitting next to one another. Okay? They have to share components. And so while we're not going to put compression water in this pre-charged tank, we're going to use a separator. And what the separator does is the separator separates the drawdown water from the air. All right? So at this point, we would like to take a poll. Your choice is true or false. Pre-charged tanks are less than half the size of their over-water tanks. True or false? And we're going to take a look at the answer here. And we've got 6 people saying true and 1 person saying false. I have to give it to the 6 people. That is a true statement. Now, I'm going to show you why the answer is true, because I always like to make sure that you understand why something is happening. Okay? So, first thing we're going to do here is we're going to take a look at that 85-gallon tank there. The 85-gallon pre-charged tank versus a 220-gallon air-over-water tank. Remember, with a 30-50 pressure switch, both of these tanks are going to give you 26 gallons of drawdown. So, here's a little math for you. If we take that 85 and divide it by the 220-gallon air-over-water tank, we find that it is only 38%. So that makes it less than 50%. Okay? Now, the next tank we're going to talk here, 85 is a pretty good size tank. The next tank we're going to talk about here is the 19-gallon tank. It is equivalent to a 42-gallon air-over-water tank. So once again, if we do that math, we find that the 19-gallon tank is only 45% of the 42-gallon tank. So you can see that the answer is true, and it's going to be true of any of the tanks you can compare. If you're comparing a pre-charged tank to an air over water tank, you're going to save room. There's going to be a lot more room because it's less than 50% of the size. All right? Now, the next little piece of math that we're going to do is what is the usable amount of water in each of these tanks? So if you take your 26 gallons of drawdown and you divide it by the 220 gallons in that tank, or that's possible in that tank, you're going to find 11.8%. Basically, I tell everybody 12%. So approximately 12% of the tank size, and this goes for any air over water tank. If it is a true air over water tank, about 12% of the size of that tank is what you're going to get out of it for drawdown. So all you have to know is what's the total size of the tank. Multiply it by 12%, that gives you your drawdown. Now, of course, if we do the same thing over here on the 85-gallon tank, we'll take that same 26 gallons of drawdown, divide it by the 85 gallons that could possibly be stored in this tank, and you're going to find that we are now at 30.5%. And again, I count that one down 30%. So once again, the important thing to remember here, if you're running a 30-50 pressure switch on a pre-charged tank, as long as you know the actual size of the tank, you can take 30% of it, and that will get you pretty darn close to what your drawdown is going to be. Now, of course, not everybody runs a 30-50 pressure switch, all right? Some people seem to require more pressure, so they want to run what is called a 40-60 pressure switch. The important thing to remember is in a tank that's got a 40-60 pressure switch on it, you're going to get 22 gallons of drawdown on that 220-gallon tank. And so, of course, if you take the 22 and divide it by 220, you're going to find that it's going to come out to about 10%. And once again, any size air over water tank, if you're running a 40-60 pressure switch with it, about 10% of that tank is what you're going to get for drawdown. And now we come over that 85-gallon tank, and we divide that same 22 gallons by that 85-gallon tank, and you're pretty darn close to 25%. Okay? Now, I'm giving you these formulas for a reason, and the reason is very simple. It will allow you to calculate how much drawdown you're going to get out of a tank, as long as you know the pressure switch setting and you know the total size of the tank. You know that if you're running a 30-50 pressure switch and a pre-charged tank, it's going to be about 30%. You know that if you're running a 40-60 pressure switch with a pre-charged tank, it's about 25%. So it gives you an idea of how much drawdown. Now, there's a reason why we want you to know that. We're going to talk about that in just a second here. Okay? The reason is simply this. The drawdown should be equal to a minimum run time of 1 minute. Now, I want you to know pump companies, submersible motor companies have been telling you this for years and years and years. And I also want you to know it's not 100% accurate. Okay? Now, the reason I say it's not 100% accurate, I'm going to go to a chart that is in the PN 793. Now, the PN 793 is our version of Franklin's AIM manual. Okay? So this chart is going to be in both books. It's in our PN 793. It's on page 24 of the current book. If you look on page 24, or if you're just looking for this chart, it's 5.10, and it's titled Starting Frequency. All right? Now, when you look at it here over on the left-hand side, it's going to give you the horsepower, and then it actually breaks it up between single-phase and three-phase motors. All right? We are going to choose single-phase. You'll notice here, it breaks the motors down horsepower-wise half and three-quarter. And then under single phase, there are 3 columns. If you look at the column on the right, it says starts per 24 hours. Now, the last time that I looked at the AIM manual, that's all the AIM manual said, was starts per 24 hours. So this is important that you understand what we're really talking about here. It says that for a single phase, half through three-quarter horsepower motor, you shouldn't start it more than 300 times in a 24-hour day. Now, if you take that 300 times, look at the top of the screen there, if you take that 300 times and divide it by the 24, you're going to see that that comes out to approximately 12 and a half starts an hour. All right, so column number 2 in here says starts per hour. Notice that it says 12 and a half. If you were to divide that out, that 12 and a half, into the cycle time here, into the amount of minutes that you're supposed to run between starts, you're going to find it to be almost 5 minutes, 4.8 minutes. So what the chart is basically saying, and remember, the AIM manual is telling you the exact same thing. What it's telling you is this, that if you have a half or three-quarter horsepower motor on your pump, and you're running that pump, you should not turn that pump on except for maybe once every 5 minutes. So between starts, there should be at least 5 minutes. Now that 5 minutes is made up of run time, and it's made up of off time, okay? There are 2 ways to cool that motor. One is to turn the motor on and make sure you move the water past it. If you move the water past the motor fast enough, it carries away the heat. That cools the motor off. The other way is turn the motor off and leave it off for a prescribed amount of time. Now, we're going to talk about this in a minute, because if you're talking here a 1-minute run time, okay, then that would mean that if we let this pump run for a minute, we want it to stay off for about 4 minutes. And this is where tank sizing comes in. It becomes extremely important. All right? Now, if you think the half through three-quarter is bad, take a look at the 1 through 5 horsepower. Again, 5 horsepower is the maximum in single phase. They are talking about 100 starts every 24 hours, which, of course, if you break that down into the number of starts per hour, it's 4.2. And if you break that down into your cycle time, you're looking at about 15 minutes. So if you've got a 1 horsepower or larger pump in the ground, it shouldn't start but once every 15 minutes. Now, to emphasize this point, I'm going to tell you the story of a guy from Connecticut. I never try to give out names. And he called me and said, Bill, I burned up 2 50 horsepower motors. Now, at the time, we were using Franklin motors. And so he gave me a hint as to what the problem was, because he says, I don't understand what's going on. I'm staying within my starts for the day. Now, of course, that prompted me to turn to the AIM manual, page, I believe it's 13 in there. And I looked at starts for the day. No, it's page 10, I'm sorry. And it says the same thing that you see here. 7.5 through 10 horsepower, 3-phase. That actually goes all the way up to 200 now. In the new books, all the way up to 200. 100 starts per 24 hours, which, of course, is 4.2 starts per hour, which, of course, is 1 start every 15 minutes. So I said to him, are you talking a 24-hour day? And he says, no, an 8-hour work day. Now, when you take an 8-hour work day and divide it by the 100 starts that he's staying to, you'll find that it comes out to about 1 start every 5 minutes. 1 start every 5 minutes. So he's taking this 50 horsepower pump, not allowing it to cool off, and then starting it once every 5 minutes. Needless to say, what happens is the heat builds up in the motor, and the heat builds up in the motor, and you don't give it enough time to cool off when you're running it, and you don't give it enough time to cool off when you're stopping it. So, of course, the heat stays there, and then you add more heat every time you turn the motor on. So you keep adding heat and adding heat and adding heat until, poof, you smoke the motor. All right? So this is why I have always tried to encourage you to make sure your tank sizing is proper. All right? So the next thing we're going to look at here now is we're going to ask a question. The drawdown, it says, should be equal to 1 minute. Remember, that's not necessarily true. How much water would a half horsepower, 10-gallon-a-minute pump set at 50 feet to water with a 30-50 pressure switch pump? Okay, I have a question here. The question is, so why choose an air over water tank in lieu of a pre-charged tank? The answer, and we do get this question every once in a while, the answer is basically that there are some times where an air over water tank will allow iron bacteria to grow. And if you've got a well that's got iron bacteria in it, it smells kind of like rotten eggs when it comes out of the faucet. Air will kill the iron bacteria. So if you've got a really strong iron bacteria problem and you can't get rid of it any other way, an air over water tank is one way to get rid of it. So you put that air over water tank on there, and of course the first thing that's going to wind up happening is that air is going to hit that, or that water is going to hit that air, and the iron bacteria is going to die. And now when you open up its faucet, you don't see that strong smell there. So that's one reason why people like an air over water tank. Okay? So I hope I answered that. If you got another question, please type it in. Okay? All right, so we're going to go back to our current question here. How much water would a half horsepower, 10-gallon-a-minute pump set at 50 feet to water with a 30-50 pressure switch pump? And we have to remember that 30 psi is the turn-on pressure, and it's equal to about 70 feet of head. So I've got an illustration here I'm going to show you. And if you add the 70 feet of head to the 50 feet that you have to lift the water, that's 120 feet in which the pump is going to start. So our picture shows us the ground level here. Remember, someplace under the ground, there's water. We're going to tap into that by drilling a well. We'll put a screen at the bottom of the well, and then we'll go ahead and we'll put our pump in the well. We're going to bring our pump over and connect it to our tank. All right? Remember that the tank is going to have a pressure switch on it. All right? So in this case, we're running a 30-50 pressure switch. All right? I'm going to come back to that. So we've got a 30-50 pressure switch here, and the 30-50 pressure switch at 30 psi is equivalent to 70 feet of head. Don't forget, we're 50 feet off the water, so if we add those two together, again, that's how we come up with the 120 feet. And I want you to understand that. That's how we come up with the 120 feet. Okay? So now, the next thing we're going to do is we're going to look at a 10-gallon-a-minute curve. Now, I'm going to show you the complete curve. Okay? But because we're going to definitely use a smaller pump here, it's only 120 feet, I'm going to go ahead and chop off the top part of that curve, make it easier to read it. Okay? And what I'm going to do is I'm going to put a smaller version of it here that you can blow up and see a little bit easier. Okay? Here is our 120 feet right here. So that's this line that I'm putting in represents the 120 feet. And the question was, if I've got a half horsepower pump, how many gallons a minute is that half horsepower pump going to pump at 120 feet? So if we go ahead and we draw a line from the 120 feet to the half horsepower pump, straight down, you'll see we're at about 11 and a half gallons of water. All right? Now, I am going to be very generous with this pump, and I'm going to say that it is 11 gallons. Now, you'll see in a minute why I'm saying this generous, because the more water you have, the worse the situation is going to be. I have seen people who have put a 1.5 horsepower pump in the same scenario. And so the question is, what is the 1.5 horsepower pump going to do? And so we're going to pop over here, and we're going to go back to that curve, and now we're going to find that 1.5 horse line and draw a line right straight down from where the 1.5 horse line crosses the 120 feet. And that is going to give us approximately 15.5 gallons a minute. All right? Now I want you to know there is an on-off. All right? Remember, it's 46 feet, 47 feet ahead is 20 psi. So notice there we put our on, which is on the right-hand side, and our off, which is on the left-hand side. And you can see the difference between the on and off. In that 20 psi that we're going to raise, we're only using about a gallon a minute. Okay? Now, here's the point. You will notice that there are dashed lines once we get past the 15 gallon a minute mark, which means for at least 50% of the time that this pump is on, it will be upthrusted, because that's what those lines represent. They represent upthrust. And of course, if we upthrust this pump on a regular basis, 50% of the time, we are surely going to wear out that upthrust protection, and we're going to lose this pump. So it's very, very important that you try not to do this, although I have seen cases where, yes, indeed, it happens. It happens. Okay? So we're going to be, again, generous and say 15 gallons a minute. Now, let's show you where we're really going with this, because what we're really going to do with this, and we want you to take a little poll here first. This poll says the most popular tank sold in the United States. You have a choice. Is it the 19-gallon pre-charge tank? Is it the 35-gallon pre-charge tank? Is it the 50-gallon pre-charge tank? The 85-gallon pre-charge tank? Or the 119-gallon pre-charge tank? The right answer is a 19-gallon tank. So the most popular tank sold here in the United States is that 19-gallon tank. And I do appreciate those of you that pick the 85-gallon, the 119, you're doing the right thing. But unfortunately, most people don't do that. Most people pick that 19-gallon tank. All right? So the 19-gallon tank, remember, we're putting a 30-50 pressure on the system here. So the 19-gallon tank with a 30-50 pressure switch is going to have about 5.8 gallons of drawdown to it. Okay? So what would the run time be for the half horsepower pump? Well, if you divide that 5.8 gallons by the 11 gallons that the pump is going to put out, you're going to find that you get approximately a 32-second run time. If we do the same thing with the 1.5 horse pump, we will see that if you divide the 5.8 by 15, because remember, now we're doing 15 gallons a minute, we're going to get a cycle time of about 20 seconds. Now that's 20 seconds on. All right? Now, let's go back to our example. All right? If in our example we are taking a shower, all right, most shower heads are going to give you 2 to 2.5 gallons a minute. Probably closer to 2 at 50, 2.5 at 60 psi. So if the shower head takes 2 gallons a minute,
I showed it, and then I came in at my normal 7.
the tank holds 5.8, we'll call it 6 gallons for simplicity, and the pump is doing 11 gallons a minute.
No, Joe didn't know. He just opened up.
It takes 32 seconds to fill it.
Yeah, Tim. He had that lost.
How long does
When I
it take
came here at
unfill?
I unplugged it at 7.
And of course, if I fill it, I've got 6 gallons of water. I'm using 2 gallons a minute. That means I'm going to run that pump I'm going to leave that pump off for 3 minutes, I'm going to turn it back on. So if I left it off for 3 minutes and I ran it for 32 seconds, you can see we didn't even hit the 5 minutes. We didn't even hit the 5 minutes. Okay? So, it's very important. Now, think about what if you use that 1.5 pump? 20 seconds. So now we're not even at 3.5 minutes, and we're supposed to be off for 15. We're not supposed to turn it on for at least 15 minutes after we turn it off. So you can see that, yeah, we do have a lot of problems when people don't size their tanks properly. Tank sizing is what makes the life of the system work so much better. All right, I'm going to go back. I'm going to answer that question now. And let's see, the question says, wouldn't it be more cost-effective to have an air burn or regular tank-sized tank though, if iron bacteria is in the system? There are different ways of handling iron bacteria. One of the ways of handling iron bacteria is to chlorinate your well. And that has to take place about once every 6 months or so. So you can chlorinate your well and then use a standard tank. Don't forget that when you chlorinate the well, you want to make sure that you put the right amount of chlorine in. So follow whatever your local codes are to make sure that it's correct. But yes, there are other ways of handling it. Air over water tank is just one of the ways. At the time that we were having some problems, it was the only way that we had. So that's why we recommended the air over water tank. So thank you for that comment. Okay? All right, now, everything that I've told you for the last 40 minutes, forget it. Okay? And the reason I want you to forget is because we're going to talk about VFDs here for a second. All right? When you have a variable frequency drive, it's very important that you understand that the pre-charge in that tank is different. And of course, it's different because you'd like to see that ratio. Remember what the ratio was. 30% water, 70% air. Okay? If we had a 30-50 pressure switch, we were running 30% water, 70% air. If we had a 40-60 pressure switch, we were running 25% water and 75% air. So what we're suggesting to you is 70% of the preset point. So if you are going to choose a tank and you want the preset in the system to be 60 psi, what we're recommending you do is take that 60 psi times 70%, and now you're going to put 42 psi in that tank so that you get the right amount of drawdown out of that tank. So that's what we're going to recommend. And by the way, for tank sizing, we would recommend 20% of the rated flow of the pump with a minimum of 5-gallon tank. All right? So 20% of the size. In other words, if I've got a 50-gallon in a pump, I need at least a 10-gallon tank. Nobody sells a 10-gallon tank. I guess you're stuck buying a 19. Okay? Then when you get that 19-gallon tank, you set the pre-charge. If you want to set point pressure at 60 psi, you set that pre-charge at 42 psi. All right. Now remember, if you're running a 40-60 pressure switch, you'd have 48 psi in there. But when you're running a set point pressure, you just take it 0.7. Okay. Now let's go back and take a look at air over water tanks. And remember, you can run those tanks with a submersible pump, or you can run them with an above ground pump. So in our next picture here, we're looking at one of the types of air volume control. And of course, we're looking at this one for a very important reason. It's the one that we make and sell. So that's why we're looking at this one. Okay? Now, you're going to notice here, it talks about normal operation. And I'm going to put a red box around normal operation so you know exactly which picture we're looking at. And I'll move the red box around as we start switching pictures. Okay? When you look at the normal operation there, you can see everything looks fine. The air in the tank is below the level at which air could move into the cup, the plastic cup, all right? So now we're going to talk about what happens when a tank needs air, when there's not enough air in the tank, all right? Remember, with an above ground pump, we're going to add air. You're going to notice there's a little ball right there, you know that arrow? That little ball floats up as water comes in through that tube. And as it floats up, it allows water to fill up that cup, all right? Then you're going to notice there's a big ball in there, and that big ball is going to serve a purpose here in just a minute. Because what we're going to do is we're going to change things now. We're going to move from the tank needing air down into picture number 1. When you get down to picture number 1, you're going to see that indeed the pump has turned on, all right? Because the pump turned on, the large ball now is being drawn down with the water, all right? Now, the reason it's a large ball is so that when it gets there, there's the large ball right there, it's going to plug that hole, all right? You'll also notice that the little ball has gotten pulled down. And instead of allowing more water to come in, now what's happening is there's an air release in there that is allowing air to get pulled in. Remember, we are causing a vacuum at this point. And that's why we're filling that vacuum up. We're filling it up with air. So now we're going to get rid of those. We're going to move over to box number 2. Box number 2 says, okay, now what we've got is we've got the ball, the big ball, sitting down on top of the hole and plugging it so we're not pulling any air into our pump. We've got the little ball pulling down so that we're not letting any more water into the cup, and we have filled the cup with air. Okay, that's the purpose of this part of the cycle. The last, the last part of the cycle takes us over to box number 3. And when we look at box number 3, what's happening here is the pump shuts off, and because the pump shuts off, there's no more vacuum on that big ball. All right? Because there's no more vacuum on the big ball, there's no more vacuum on the little ball. And so now what winds up happening is we get a mixture of air and water. Air moves into the tank, water moves into the cup, lifting up the big ball. All right? We're going to move on then, and we're going to take a look at how you would do this with a submersible pump. Now remember, with an air over water tank and above ground pump, you can waterlog the tank. All right? Remember, a waterlogged tank is nothing more than a big piece of pipe. All right? When you are doing a submersible pump, you are going to use a little different method. You'll notice down here in the well, generally speaking about 10 feet below that check valve, you're going to put in a bleeder orifice or 2. What the bleeder orifice does is this. When the pump turns off, the check valve holds the pressure from the system up in the system. Okay? The pressure down here on the pump is relieved a little bit, which allows a little ball that floats in that bleeder orifice to float up and allows the water to flow out. So the water flows out back down into the well, and air fills up that section of pipe. Okay? So that check valve is very important. The placement of the check valve is very important. You want it near the top, about 10 feet above the bleeder orifice. All right? Now, the next thing that's going to happen, you're going to notice when the pump turns on, the water pushes the ball against the hole and closes the hole. All the air that was trapped in that 10 feet of pipe is now being pushed up with the pressure from the pump is making and into that tank. All right? As that air goes up into the tank, what winds up happening is we've got something that is made by Robert Shaw. Okay? And basically what it's got there is you've got that paddle on the end. Well, as the air comes in, the paddle drops down. As the paddle drops down, In this section right here that screws into the side of the tank is going to be a snifter valve. And so as that paddle drops down, the snifter valve is pushed open by the paddle, the weight of the paddle going down, and that allows excess air to escape the tank. In other words, when you have a submersible pump, the problem is not going to be waterlogging the tank, the problem is going to be air locking the tank. And so to prevent that air locking, you use a Robert Shaw and therefore allow some of this air to escape. One time while I was traveling with the installer up in Minnesota, central Minnesota, we went to a guy's house. He had a 220-gallon air-over-water tank in perfect working condition. The problem was he didn't have any pressure. Now, of course, when we get to the job site, there's 60 pounds there. And I'm like, what's the problem? You got 60 pounds of pressure. And the guy says, yeah, well, watch this. He walks his back out through his big screen TV room, up the steps, and outside to where he's trying to grow grass. He hands me a hose, and he turns on the water. And that water's just spraying out with 60 PSI behind it. And I said, what's wrong with this? He said, just wait. So about a minute, minute and a half later, the next thing I noticed was that the flow had turned down to a dribble. And if I wanted to, I could put my thumb over the end of the hole in the hose, and I could stop the flow of water. So I set the hose down, I went down in the basement, and now the pressure switch is only charging at 8 PSI. And then I hear a glug, 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 whoosh. And I thought, what the heck is that? And then I watched and I saw the pressure gauge. The next time I heard the glug, 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 whoosh, which was a minute or so later, the pressure gauge went up 2 PSI. They had turned the water off and they came back down in the basement. Now, of course, the whole time that this is taking place, we're putting air into that system. It doesn't need air, and so the paddle is dropped down, and all you can hear is whoosh, as that snifter valve is allowing the air to escape out of that tank. So when Butch came back in, I said to him, Butch, I think I know what the problem is. He says, what's that? And I said, listen. And we heard the glug, 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 whoosh. What happens when a pump runs out of water? Well, what happens is you pull air into the pump. When the air hits the check valve in the pump, it closes the check valve because the pressure above it is too high, and so it can't. The air doesn't have any support and doesn't hold that check valve open. So the check valve closes. Now more air gets pulled in. As air gets pulled in, water gets pushed out. Pretty soon you airlock the pump. Now the pump is dry running until enough water builds up in the well to create enough pressure to compress the air in the first impeller and force water in that first impeller. Once water gets in that first impeller, now it pulls the water in, pushes the air out, and so you get a glug, glug, glug as the air comes up, and then the whoosh is the water coming in, and of course what happens next? You've lost prime again. So that's what was happening. And of course, his tank was just making noise like crazy. So we talk about what is the answer to the problem. And Butch says, well, I can throw some chemicals down the well. You've probably got a plug screen. And he says the chemicals may or may not open up the screen. It costs you about $100. Okay? If you don't want to do that, he says, I can drill you a new well. I'll sell you a new pump, and I'll put in a new tank. And now notice how it rolls off his lip for $169. Now, of course, what tank is he selling for $169? The best or most popular tank sold in the United States, a 19-gallon tank. He's going to sell this guy a 10-gallon-a-minute pump, which is exactly at the situation that we were talking about earlier. He's 50 feet to water, 57 to be exact. 57 feet to water, and he's running a 40-60 pressure switch. Okay? He's going to kill the pump because he's not going to get the runtime on it. Now, of course, he wants to sell him a 19-gallon tank. The guy has a perfectly usable air over water tank that's 220 gallons, which would now make the runtime on that 10-gallon minute pump at least almost 2.5 minutes. Much better choice. Now, I don't want to diss the sale. After all, this is my installer, okay? So I don't want to diss his sale. So I step between him and his customer, and I take a risk, and I say to the guy, you know, there's absolutely nothing wrong with this 220-gallon air over water tank, with the exception of the shh that you're listening to when you're sitting in there watching TV, and you may not want to hear that. So if you put a pre-charge tank in, you'll eliminate that problem. But if I'm going to put a pre-charge tank in, I would strongly encourage you to put an equivalent to this 220-gallon air over water tank, which is an 85-gallon tank. And then I step back, and I don't know if Butch got the sale or not. All right? Now, the next thing we're going to talk about here is construction of the tank. And you're going to notice that it has a cold rolled steel construction outside shell. Okay? It's a 14-gauge steel. You can see it's going to be welded. We're going to roll the body and then weld it right down the middle. We call it a seam welder. If you come to the factory schools, by the way, I take you on a tour and I show you how all this is done. Then they're going to clean that steel, and then they're going to go ahead and they're going to weld the top and bottom heads on. Now you can see the top head is going to have a small hole off to the side. That's where the air volume, that's where the snifter valve is going to go. We make two types of tank. We make a PS tank and a PSP. The PS tank has a rubber snifter valve, and that's that tank that you see there. There's a cap that goes over the top of it. You're looking at the cap there. If you look at the bottom of the tank, we cut it away so you can see the flange. That happens to be a plastic flange on there, and that's your PS tanks, all right? If the tank is a vertical tank, all right, you're going to have a bag in here. We have redesigned the tank so that way the bag will expand and fill the whole inside of the tank. Now, we're redesigning this from is our old CA or captive air tanks. By the way, I just talked to a gentleman last week who called me up and said, I have a 16-year-old CA tank. Do you think it's worth selling? My answer was no. It's not worth selling at 16 years old. Don't be silly, okay? But it does show that these tanks do last. And so, of course, what we did is in the old CA tank, we had a smaller bag, and when the tank ran out of air, the bag would explode. And so we redesigned this bag so it will completely fill the tank without exploding. So that was the purpose of that part of the redesign. Another part of the redesign was, on occasion, the tank bag would collapse, and instead of letting all the water out, it would fold in on itself, cover the hole, and now you couldn't get all the water out. So we put a standpipe in there. All right. We realized very quickly that that standpipe had to have a hole in the bottom of it, because the bottom line is you had to equalize the pressure inside the standpipe. Otherwise, you'd create a vacuum in there and suck the bag in. That didn't work very well, so of course we had to change things a little bit from our original design. But now it works, and we've got that standpipe in there to help us empty the tank out completely. All right. So now what winds up happening is the air is on the outside of the bag, and you can see it collapses the bag from all directions. And with that standpipe in there, that's going to force all the water out, which is what you want. If you have properly charged your air tank, there will be maybe a cup of water in there when that pump turns back on. And that's what you want. It's a very small amount of water in there when that pump turns back on. All right? So now I'm going to show you a picture of our family of PS tanks. Remember, PS means that we are using a rubber snifter valve that's going to be underneath that plastic cap there. And you can see by the horizontal tanks here, we've got a plastic flange. All right? On our ProSource Plus or PSP tanks, you're going to see that now we have a steel snifter on there. And along with that steel snifter, we are going to put in a stainless steel flange. It is designed to have a hole in the exact same spot so that you can change one tank out for the other. You can even change that tank out for an old CA tank. Most tanks have their opening right in the exact same spot. All right? This next illustration here, and again, I'm calling it an illustration because that's exactly what it is. It's an illustration of what happens inside the tank. And so you can see in tank number 1 here, or tank number A, you'll notice the pump is just turning on and we're filling the bag up with water. Tank B shows that as we fill that tank up with water, we are compressing the air that's inside the tank. Tank C has the bag full of water. Again, it's an artist's conception, because the bag is actually going to be touching the outside edge of the tank at the bottom. And then, of course, D shows us how that air decompresses as our pump is turned off, and now we're relying on the pressure inside the tank to feed our system. All right? So, true or false? Bigger is better. The answer is true. The answer is true. Bigger is better when it comes to tank sizing. And again, let's show you why we believe this to be the case, okay? We're looking in the Stay Right catalog, page 114, and again, I'm not sure which year this is. That's this year's catalog or last year's catalog. But you'll notice there is a tank selection chart. It's chart A. There's actually 2 charts, chart A and chart B. Chart A says, okay, we're going to run this chart this way. And so you'll notice with chart A, that it is a tank selection chart, and it's going to tell you, are you running a 20-40 pressure switch? Are you running a 30-50 pressure switch? Or are you running a 40-60 pressure switch? So it's asking you which pressure switch you're going to be using. Okay? Now, right underneath the pressure switches, it gives you what is called the run times. Run times. Okay? And you're going to notice, I'm going to pick the 30-50 one there. It's got a 1-minute run time, and right next to that 1-minute run time, it's got a 2-minute run time. Okay? If you look over to the left-hand side of the chart, that column says pump flow in gallons per minute. Now remember, you need to do like we did before. Calculate what the pump is going to do, not what the pump is rated at. Our pump was rated at 10 gallons a minute, but as a half horse, it was going to do 11 gallons a minute. As a horse and a half, it was going to do 15 gallons a minute. Okay, it's page 116 in the 2011 catalog. Thank you. Appreciate that. So if you're in the 2011 catalog, it's page 116, which means 114 must be the new catalog. Appreciate that. Thank you. All right, now, our flow rate on our pump was 10 gallons a minute. Okay? So if we go across from there and we say, okay, I want to have a 1-minute run time, what it's going to tell us then is that you should have a minimum of a PSP 35. All right, that's the minimum tank you should have. If you want that 2-minute run time, which is even better, now you're going to have a PSP 62. Okay? Now again, remember, the most popular tank sold in the United States is that PSP 19T. Okay? And I have been asked, why do you make that tank if you don't want me to use it? And I got to tell you the truth. Because if you look over on the left-hand side of the picture there, the truth is we make a 5-gallon-a-minute pump. And since we make a 5-gallon-a-minute pump, that 5-gallon-a-minute tank is going to work just fine with it. Okay? So it's kind of important that you understand sizing is very important. And when it comes to tank sizing, the bigger that tank, the better your system is going to work. All right? Now, there is another way to check it, and I'm going to just take a guess that page 115 in your 2011 book is what we're going to look at. I think it's page 113 in your new book here. And what this page shows us is it shows us the chart that's in the book, and it gives you the tank model numbers on the left-hand side. So you'll notice over here, page 118, thank you, appreciate that. So you'll notice over here is your catalog number. Then it says the maximum capacity. Remember what I said, 30% for for recharge tanks based on the maximum capacity, and that's what this is telling you. So you can take 30% of each one, and it's going to come out to the answers that you're going to see here in a second, all right? Then it gives us some dimensions. It gives you your diameter, it gives you your height, it gives you the pre-charge at the time that we send it out of the factory, and it gives you your connection type. Remember, we're using female on the tank, so it's an NPT 1 inch for 35 or less, inch and a quarter for 50 or more, okay? Then you've got your next column here, which is going to be your drawdown in gallons or liters per minute, all right? And with that, it gives you your three pressure settings that people most often use, 20-40, 30-50, 40-60. Now, this chart works a little differently. In this chart, you're going to pick your pressure setting, and then you're going to go down to the flow rate that you're looking for. So we're looking for about 11 gallons a minute. Right there, we got 10.7. So with that half horsepower pump, we're saying we need at least a minimum of a PSP 35. That's the minimum, is a PSP 35. Everybody understand that? If we wanted to, we could double that, and you look at that 18.3 is your 62-gallon tank there, so you can see what you'd be getting out of there. So very important that you understand how to do tank sizing. All right? We're starting out with our pump down in the well. Remember your pump, the submersible pump, that's got the pump and the motor right on it. There's going to be electric cable going down to it, okay? Typically, there's guys are going to take that electric cable and they're going to tape it to the piping system, and especially if they're using, well, they tape it to any pipe system, to be honest, okay? You're going to notice that we included a torque arrestor here. This is extremely important if you're going to use plastic piping, because plastic piping twists, and that pump is going to cause some torque. So if you don't put the torque arrestor in, that twist goes all the way up right to that pitless adapter, and eventually you could break the pipe. So that's why we're going to strongly encourage you to put in at least one torque arrestor. All right? Then you're going to find that the next thing we've got in place here is it says a check valve. You'll notice that a small box appeared on the top of the pump too, because most pumps are going to have a check valve at the top of the pump in that top head. And then we're going to recommend another check valve every 200 feet vertical. So it's not 200 feet of pipe, it's 200 vertical feet, okay? The next thing we're looking at here is the pitless adapter. For those of you that are up north, we all know what a pitless adapter is. If there's anybody from down south, you might say, what's that? All a pitless adapter is a fancy elbow. Now, the point is the pitless adapter has a part, and you can see it is on the right-hand side of the pitless adapter there, that it's attached to the well casing itself. And it seals the hole that you have to drill to put that pitless adapter piece in there. So that way you're not going to get dirty water or dirt going down in your well. Okay, you're going to actually seal that hole right off. Then it's got another part, the part on the left-hand side, which has got a wedge in it that's going to fit into that other part. And basically, it's an elbow. It's just a fancy elbow. Now you'll notice the person who put this one in left a piece of pipe in the top of it. Most people don't do that. Most people will take that pipe out of the top, all right? They screw that pipe in, and then they can lower the pump that way, all right? And then when they get the pump lowered onto the pitless and they know they're on the pitless, now they just unscrew that piece of pipe and take it back out. When they want to pull the pump back again, set the piece of pipe down back in there, screw it back in, pull the pump up. All right? So that's what your pitless adapter is for. It takes you from the vertical to the horizontal under the frost, and that's the important thing. We're going from the vertical to the horizontal under the frost line. That way your water doesn't freeze. If we do like you guys down in Florida do, and we just come right up out of the top of the well and go back down to the ground, our water's going to freeze and we're not going to get water in the house. So we have to use a pitless adapter when we're up north. Okay? Now, there's your well cap. Remember, you want your well cap vented and screened, so make sure it's vented and screened. Okay? The next thing we're going to look at here, we're going to get inside the house, and there's our disconnect switch. Now, I want you to know the disconnect switch is not the beginning. Disconnect switch is not the beginning here, okay? The main breaker box is the beginning, okay? So whenever you're sizing your wire, you're sizing it from the pump motor all the way to that main breaker box. If you have a electrician put that breaker box in for you, that disconnect switch, then make sure that he sizes that wire right. If he doesn't size it right, then you have to compensate when you go down in the well, okay? You're going to go from the disconnect switch to the pressure switch. If you're using a 3-wire pump, you're going to go from the pressure switch to the control box, all right? If you are using a 2-wire pump, you're just going to go right straight down the well, all right? That makes up your electrical system. Now on the inside here, we've got our pre-charged tank. There is a pre-charge in this tank. You have to make sure that it is set properly when you are going to use this tank. In other words, we mentioned we're going to put most of those tanks out there at 40 psi. So if the tank is at 40 psi and you're running a 30-50 pressure switch, you will have problems with that tank if you do not let some of that air out of that tank. Because you should have about 28 pounds of air in there with a 30-50 pressure switch. With a 40-60 pressure switch, 40 psi, you want to take a couple pumps out. So just make sure that you check it. And then again, remember, it's like a car tire. It's going to lose air. If you don't check it on a regular basis, it says we give you a 5-year warranty. The 5-year warranty is for manufacturer's defect. Air in the tank is not a manufacturer's defect. That's something that somebody has to check. If you don't want to check it, have your customer check it. Show them how to do it and tell them to do it, okay? Because if it's not done and that tank fails, technically, I'm saying that with a bunch of salesmen on the line, they will probably argue with me, but technically, it's not a warranty, okay? Just so you all understand that, all right? Now, we've got a tank T coming out of the tank, and we're going to put a drain cock on that tank T. The main purpose for the drain cock is so that once you get your initial setup in there and you've got the pre-charge check, you can go back 6 months later, hit the disconnect switch, turn the pump off, open up the drain cock, drain the tank out, and then pre-check that pre-charge again. Okay? So that's basically what that drain cock is for. Everybody loves the pressure gauge. Now, we all know they don't last very long in that situation because they're getting beat up all the time, but everybody likes the pressure gauge, so put your pressure gauge on that system. And then lastly, I mentioned this earlier, and this is so extremely important. Put on a pressure relief valve. And I know some of you are thinking, well, what the heck? I got a pressure relief valve at the hot water tank. Why do I need another one? Because it could save your life. Okay? Now, what do I mean by that? Well, what I mean by that is this. If that tank blows up and hurt somebody, it can kill somebody, or it can destroy property, which eventually could wind up destroying your livelihood, okay? So this one's not so bad, but if you look at this next tank system here, what wound up here was the pump didn't turn off. So because the pump didn't turn off, you can see this was a rocket. And it took off from this block building, and it went 200 feet across this little channel and landed up in the street over there. Okay, there was a woman, house is not in the picture, but to the left-hand side where that arrow was pointing, there was a house, and a woman was sitting on the front porch and saw the whole thing. So, and look how it just blew those blocks right off the concrete pad there. Trust me, if you'd have been in there, you wouldn't have wanted to be in there. Okay? So this is why we say be very, very careful and make sure that you get that pressure relief valve on, because the life you save could be your own.